Jai Jirendra, Namaste, welcome to my channel. Today we are going to solve the 36th question of the problem solving series, which is based on binary search. This is the 6th question of the binary search and maybe the last question of the binary search in this playlist. And this question has been asked in Facebook, Google, Oracle and Uber, and the difficulty level for this question is medium. So let's discuss. We need to find the single element in a sorted array which is not duplicate. So we are given a sorted array where the numbers are duplicate, it's repeated twice. Okay, it's repeated twice, it's given. Only one element is there which is not repeated twice. We need to find that repeated, that non-duplicate element. For example, here we can see 2 is not repeated. All the other elements are repeated and it is sorted array. So we need to return maybe the index or the number, anything. Say we need to return the index. So this is the second index element which has not been repeated. Here in this case, 0, 1, 2, 3, 4, 5, 6. And we see this first element has not been repeated. So we need to return 0. Okay, now how do we solve this? If we solve it without using binary search, normally we can just keep on comparing the first and the next element, whether they are same or not. So 1 and 1. Only there is one such element which is not repeated, right? So this 0th will check, okay, if this is the duplicate, then we will go to the next element. So if alternatively, we will keep on checking and we will get our answer, okay? But in this way, our time complexity will be order of n, right, normally. But if we apply binary search, then our time complexity is order of log n. Since it is a sorted array, we can easily apply binary search. But then how do we solve this problem where we don't know which element is non-duplicate, right? What is the property? The non-duplicate element, whatever is the non-duplicate element, it would surely be not equal to its previous element. Say if it is starting with 0, 1, 2. Okay, so 0 and 1, they are the same, right? Now the second index value, it will not be same to this and it will not be same to this element also, right? So if we get the mid, we have low, high, and we get the middle element, and we see that okay, this middle element is not equal to this previous element and not equal to its next element. So we have that index, we can return that index, right? But if we see that say it is equal to one of them, the condition doesn't valid, is not validated, then how do we eliminate which half? Okay, so in that case, say in this example, 0 and this one is 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, 0 plus 8 by 2 is 4. So we have this as mid. Okay, and this is equal to its previous element. Okay, and so this condition it can't be returned. So here we have got this middle element over here 3. Now this 3 is equal to its previous element. Okay. So this means this is equal to its previous element and the mod value of 4 mod 2 is 0. Okay. But it should not have been equal to its previous element because it should have been equal to its next element. Because 0, 1, 2, 3, here everything is, if it was equal like this, it is equal to like this, it should not have been mod. That means there must be some element over here which has not been equal to its previous element or its next element according to its position. So we understood that since it is equal to its previous element and the mid mod 2 is not equal to is equal to 0, that means we need to search in the left half. Okay, now if we search in the left half, 0, so the high would become mid minus 1, which is 3, so 0 and 3, and our mid would become 0 plus 3 by 2, 1.5 is 1. Okay. So mid is 1, 0 and 1. This 1 is actually equal to its previous element and it's not equal to its last element. So this condition is not fulfilled. So now where will we go? Okay, now this 1 mod 2 is equal to 1 and this condition is not equal to its previous element. That means we have issue over here. So we'll move low equal to mid plus 1. And then we will have low as 2 and high as 3, 2 plus 3 by 2, it's 2. And this element will get as mid and this is not equal to its previous and not equal to its next, so we'll return the mid. Let me code it. Okay. So we have n is equal to array dot side. What are the edge cases? The edge cases is if n is equal to 0 or n equal to 1. So this single element only return 0. Okay. What is the other condition? If array of n minus 1 not equal to array of n minus 2. Okay, that means last element is not equal to its previous element, then we will return n minus 1. Of course, if array of 0, for example this one, is not equal to array of 1, that means we will return 0. Right? These are the edge cases. Now we will go back to our binary search logic. In low equal to 1, high equal to n minus 1, while low is less than high. Okay, we have mid equal to low plus high by 2. Okay, if array of say is A, okay, let's say if A of mid is not equal to A of mid minus 1, okay, if this array of mid is not equal, if it is not equal to mid minus 1 and A of mid is not equal to mid plus 1, that means return mid. That is the unique element. Okay. Else if mid mod 2 is equal to 0. In this case here, mid mod 2, 4 mod 2 is equal to 0, and A of mid, since it is 0, if it is equal to this element, okay, A of mid is equal to A of mid minus 1. What does this mean? That it is equal to this and mid value is equal to 0. It should have been equal to this one. It is not equal to this one, it is equal to this. That means there is some issue over here. High is equal to mid minus 1. Else low is equal to mid plus 1. Okay, and then here we will have our answer. If we don't get any answer, we will return minus 1. So I hope this concept is clear. How array of mid is, if it is mod 2 equal to 0, that means it is actual odd number and it should have been equal to its even number. But if it is not equal to its even number and it's equal to its previous element, if it would have been this condition, it would have been fulfilled, then we would have got our answer. But if it is equal to mid minus 1, that means it is not equal to mid plus 1. So that is an issue. So we will be moving to the left half. So every time we will be eliminating one of the half, and this way we will be able to find the single element which is not duplicate. So the link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section.
Here is the code walkthrough section of the finding the single element in the sorted array, the non-duplicate. The difficulty level is medium, and you can see in the LeetCode platform. And the companies that has in which this question has been asked are these companies. So yeah, moving back to the code, you can see here we have added these conditions, the edge cases, and we have this condition where whenever this pick elements condition is fulfilled, it is greater if it is not equal to mid plus 1 and not equal to mid minus 1. That means this array has to be this has to be returned. And in the left part I actually missed one condition, that okay, if it is an odd element and this condition is fulfilled, that means the other part are sorted, we need to move to the left half. But also if it is an even element and this condition is fulfilled, the first part, there are two conditions that has to be fulfilled. In that case also we need to move to the right half and eliminate the left half. If both of these are not true, say if mid dot mod 2 equal to 0 and mid equal to mid minus 1, that is the condition, then we would be eliminating the right half for obvious reason which I have explained. And if we don't have any peak element, then finally this will break, the high will become greater than low, and we will be returning say -1 as it has been asked probably in the question. So let's run this code for these examples, and you can see this has worked. 2 is the single non-duplicate element, and in this is case 2. 10 is the single non-duplicate element. So let's submit the code. So this has worked fine. So I hope the explanation is clear, the code walkthrough is clear. And with this I will be moving to the next topic, that is greedy algorithm, and I'll see you in the next video where I'll explain the 37th question of the problem solving series, which is based on greedy problem. Thank you. Jai Jinendra.